Today we're going to create a end-to-end workflow, or rather we'll create a model in PerceptiLabs, export that model, and then use that model outside of PerceptiLabs. In this case, specifically we're using Streamlit to create a little app around that model. And let's get started. So, since the focus is going to be more on getting to the end, I won't be iterating on the model or using any fancy dataset. Instead, I'll actually just use the standard image classification model. And this will work the same with any other model, but this one's easy to show how it works, and you can get pretty understandable predictions from it. So, yeah, I think most here are familiar with the image classification template, but if you're not, how it works is we're just feeding in some data. In this case, it's flattened, and that will be important later on. And what flattened means is that the image, we're taking pixel by pixel and showing them in a 1D array. Then we're shaping it into an image. We're running it through convolution layer and a dense layer. This is the deep learning model, and then we're just comparing it to a bunch of labels and training it based on that. So with all of that in mind, we just press start. This should work straight off the bat. There's no additional settings we need to set up for this. And as soon as it starts training, we can, as usual, keep track of the progress. And of course we want a good model, so we can see here kind of how it's classifying each sample. We want the blue line to be the same as the yellow line, where the yellow line is the ground truth for the labels. We can also keep a look at the accuracy to see that it's increasing, and apparently it's not classifying very well on these validations, but it should get better over time, maybe. If not, the average validation accuracy seems pretty good. So as soon as training is finished, we can test it real quick, just to make sure it's working as we want it to. Currently, the test we have here just takes you through sample by sample of the input data and showing how it's outputting compared to the label, or compared to what it should be. So it's a great way to do a quick debugging of how your model performs on your test data set. We have a lot more cooler tests coming up soon as well, where you can see difference. Well, you'll be able to compare different models, and you'll be able to see a bunch more statistics, and get more information about the model, more than just seeing how the prediction is doing. So look forward to that. Anyway, this is the training part of it. Now that the model is trained, we can simply just export it. And just go to the file, export, and from here you choose where you want to export it to. So I have prepared a little folder called Streamlit, which we'll be doing, or where the Streamlit program is in. And here I prepared a bunch of images we'll try out, and a little script I'll show in a bit. But just to make it simple, I'll export it straight into here. And we don't really want compressed or quantized. I mean, we could do that to speed it up. Compressed is what you usually want. That essentially freezes it, and you usually want that on a smaller device, while quantized is for IoT. But here we can just use this regular model. It's still the prediction is still very, very quick. As soon as we export it, we'll see a little folder here pop up. And inside this folder, called by the model, we'll see a 1, which is a TensorFlow standard. And in here we have the saved model, and we have a few variables. The saved model in itself will be your model graph, so TensorFlow's representation of this one, while the variables are all the coefficients and all the weights. So now the trick is how we get this thing into Streamlit and actually start using it for forward passes, or for inference rather. And I prepared a little script already, just to make it a little bit faster so we can walk through that one. But there are quite a few ways I noticed to load TensorFlow models, and it's not very well documented from TensorFlow side. We're saving it with something called a easy saver, and if you look into the source code of this one, you'll be able to find it. Should be right here somewhere. Oh, this is the tests. Here we go. A simple save, it's called. So that's a function we're using, and it essentially just prepares everything for you. Otherwise, you would have to specify your own different tags and so on. But here you just say what you want as output and input. And yeah, the easiest way I found to load these models, you can of course load the entire model and as a graph, and from that graph manually pick out the different variables or different tensors that you want to input data into and extract data from. But this seems a lot quicker. So what you do in TensorFlow 1 at least is you enable the eager execution. This is so that you won't have to do a assess run every time you want a new prediction. So it's really handy for this kind of inference. Then loading the model is as easy as just using this function, the load v2. And then you have to say which kind of, or the inference is going to be your model. And what this little function does is it takes the model you loaded, and you can input about, when I said tags, that's going to be very similar to the signatures. You can have different tags for training, different tags for serving, and so on. And depending on which one you take, you're going to get different parts of the graph. In this case, we want serving, and this makes it really handy and easy. So you just say that you want this serving default, and you got a model which is ready to start running. For the predict part, all we do then is just very similar to how you do in Keras. You take the model and you input some kind of value into it. Beware that you might want to cast it to the right type, and the data itself needs to be a constant or something. I'm sure you can have a TensorFlow variable as well, but in this case, a TensorFlow constant was very easy, just to wrap the data around with. And then you pick out the output from the model. The last few lines here is just getting the actual prediction, which is going to be the argmax of labeling. The labeling itself is a tensor, so I convert it to numpy, and I take out of 0 because it's double wrapped. It's a double list, a list and a list. So I just clean it up like that. But that's essentially everything you need to do. Then you have a loaded model, and you have a little function which is ready to start predicting it. The rest of this part is going to be Streamlit code, and to go through quickly what this does is, well, first of all, I point to where the model is, and that's the one which we saw here. And important with this one, you want to point to the it doesn't load a specific PB file. It uses a very similar way that TensorFlow serving does, where you point to a specific folder and everything else happens behind the scenes from TensorFlow. So just point out whichever folder it's saved in, and then we kind of build a little app using Streamlit. So we set a title to it, we set a nice little image for it, and you'll see all of this as soon as I run it. Before I start running it though, the other thing which is somewhat important, you saw that I had a bunch of images here, which were actual images. And if you recall, we take a 1D array here. So we do need to do some pre-processing. And of course I could have completely skipped this by just reading these images into here instead and not had the kind of squeezed input and then do the reshaping and everything. But just to point out how you would do the pre-processing. So in here you'll get access to your image, and as soon as you have that, you can very easily normalize it, and normalizing an image is dividing by 255. So instead of 0 to 255, it'll go between 0 and 1. Makes it a lot easier for training, and that's why we take that as an input to the model. Hey Pierre. Then last thing we need to do is just reshape it. So we take whatever image we have, we make sure to resize it, meaning subsample it or making it smaller. And we know it's going to be 28 by 28. And after that, we just reshape it into this array we saw as input. And that's pretty much everything. The rest here is just a bit more Streamlit code and the actual classifying text. But let's run it and see how it looks like if I can find the right console. Here we go. Seems like it was already running. So you would just do a Streamlit run classifier. That's not how you spell classifier. And it's going to start. And here's the little app. So you can also behind the scenes see what's exactly going on. If you're loading it with this way, you're going to get a bunch of warning messages. You can ignore them. These are just for the optimizer and everything for the training part of the model. We don't care about that. We're not using it in the inference, so just ignore that. But in the app itself, we can now load a file. So say that we load a number 4, and then we classify it. We'll show up the little number 4 here. You'll see the prediction, and it's pretty confident that it's the number 4. Similarly, number 6, and so on and so on. So yeah, that went quicker than I thought, but that's the end-to-end workflow, how to build a model from PerceptiLabs, train it, export it, and then build a quick little app around it. Besides, there are obviously more tools than just Streamlit which you can use for this. The absolute simplest one would probably be setting up your own little server for it. But I'm trying this one out. It's pretty fun. Here we can also see all the printouts in the terminal. So yeah. Now, We can dig in a little bit more into how the actual saving works. We did a lot of testing before. Also, one heads up, there seems to be a small bug in PerceptiLabs right now where if you export something, it exports without the weights. So we'll push out a hotfix for that tomorrow, so you guys can follow this along. Otherwise, you'll get a lot of random values rather than the actual classified ones. But some other ways you can export it in is, or other ways you can load it in is, for example, here you're using, again, just loading it. Here you need to use a tag. And you also have to specify exactly which part of the model you want as input or output. And more specifically here is we need to specify this because we're loading the session and we're loading the graph and everything. This way is really neat if you want to try out different parts of the graph or have different parts as output rather than the one PerceptiLabs put as default. We also have two different ways to send in data from PerceptiLabs after you export it. One way is using this placeholder, which I just now used, which is great for reactively sending in data. But PerceptiLabs in itself, or the training layer in itself, is actually built with an iterator. So if you want, you can always replace this placeholder with an iterator, and all you need to do then is to do like that instead. So taking that part of the graph. And having an iterator rather than a placeholder is great in case you want to constantly sending value as soon as they go through, or just loop through a bunch of values if you already have an existing database. Yeah, other ways. I think I will make all the, or at least this script public as well, so you guys can try it out. But other than that, I don't know how useful it is to go through all of these different types of code. We can try playing around with a few different values or a few different images if you guys would be interested. Otherwise, if you have some other type of model you would want to see be exported, or let's see. Or some questions. But let's try this one. I'm sure we will be able to find some different mistakes and some different interesting classifications in this one. These are also all 3000 images from the original training and testing dataset. If you want to convert your NumPy dataset into images, it turns out it's pretty easy. You just make a for loop, or you load in the NumPy file, numpy.load, make a for loop, and then just use pill to print out these images. So the last 3000 of these, or the last 300 of these ones, are going to be the testing, the same ones as in this testing data set. So we should be able to see that they give the same value and look the same, which they do. Okay, so as I said, it went a lot faster than I thought, and I don't have anything really more cool to show than apparently how much quicker it was to get this up and running than I thought. So I have 10 more minutes if someone has any questions they want to ask, but otherwise I'm going to call the stream a little bit earlier and wish you all a great Thursday, Friday and weekend. All right. Then doesn't seem like there is any questions. Oh, never mind. It's great to be able to create models in a great way with PerceptiLabs. Is there a tool to create an app in a visual way as well, instead of using code as Streamlit? Not that I can think of on top of my head. I mean, there is tools for creating websites, as you may be aware of, but not for a data app. Maybe someone else in the chat has a recommendation for that. Doesn't seem like any other recommendations for tools like that. If you're in Slack, you can write your Slack name here, or if you're in our forum, and if I find any, I'll just ping you in either Slack or the forum. But yeah, then thanks a lot for viewing, everyone, and have a great continued day, and I'll see you all in 2 weeks. Take care.